As if the solar system couldn't get any more fascinating, a brand new study suggests that oceans of water may be hiding within planets Uranus and Neptune.
So we don't know much about them. And when we did go by, when we sent probes in the 80s, we found that they behaved, especially their magnetic fields were really odd. So it told us we didn't understand what was going on inside.
Are quite visible to the unaided eye at night. So no one person is credited with any of their discoveries. Cavemen saw these planets.
Somewhere far beyond the warmth of the inner solar system, something is misbehaving. Neptune, the icy blue sentinel at the edge of planetary order, is starting to break the rules. Not political, not social, physical. And according to new data, revealed publicly for the first time by astrophysicist Neil deGrasse Tyson, it might not be the planet we thought it was. Because the math doesn't work anymore. Before we dive in, subscribe to join us as we follow discoveries just like this. And if Neptune's mystery grabs your imagination, drop a like so more people can trace it with us. Let's begin. 4 generations, Neptune was the quiet one, the 8th planet, the farthest of the known giants. Discovered in 1846 not by telescope, but by mathematics. It betrayed its presence by tugging on Uranus, subtly disrupting another planet's path. That gravitational anomaly led astronomers to plot its orbit before they ever saw it. It began as an equation, and now it's returning to that form. Only this time, the numbers are collapsing. Tyson's revelations weren't expected. What was intended as a routine update during a global astrophysics forum quickly evolved into something else, a warning. Data gathered by the James Webb Space Telescope, reinforced by Earth-based radio interferometers, shows Neptune emitting gravitational, magnetic, and thermal patterns that don't line up. Not with previous models. Not with current expectations. Not even with Newton. Here's what was found. Neptune's internal structure, once thought to be a neatly layered stack, rocky core, icy mantle, gaseous shell, is behaving more like a turbulent sphere, riddled with inconsistencies. Pockets of heat, zones of reversed magnetic flux, regions deep within the planet that are warmer than they should be, without any external energy source. This isn't just an anomaly, it's an internal contradiction. One of the key discoveries? Neptune's magnetosphere is not only tilted, it's changing. Sections of the magnetic field are drifting over time, shifting like weather systems across the inner layers of the planet. These aren't surface storms. They're deep magnetic flows, like rivers of charge moving through a maze of exotic materials. And the data suggests those materials might be non-uniform, not melting but cycling, which has led to the single most disturbing possibility in the entire report. Neptune might be hollowed. Not empty, not artificial, but structurally stratified, with cavities or chambers acting as acoustic and electromagnetic resonators. That's not how gas giants work. But this isn't behaving like one. Tyson used a phrase that stunned the room. We may not be looking at a failed planet. We may be looking at a miscategorized object. According to gravitational modeling based on JWST's lensing and thermal echo scans, Neptune's interior doesn't compress evenly. Certain layers refract incoming waves, both infrared and gravitational. That would suggest that parts of Neptune bounce energy back into space. Like sonar. Like something trying not to be seen clearly. And then there's the heat. Neptune orbits 30 times farther from the Sun than Earth. Its temperature should be stable. Cold. Passive. But patches of it are getting warmer. And not slowly. New measurements show hotspots appearing deep below the cloud cover, far below the level where solar input could penetrate. And unlike typical atmospheric anomalies, these patches don't move like weather. They pulse. In sync. The hypothesis? Neptune contains superionic ices, materials that exist in a hybrid state, not quite solid, not quite liquid. In labs, these are water molecules with dissociated hydrogen atoms, forming a high-pressure, high-conductivity soup. If Neptune's interior is rich in these phases, then vast electrified currents could be forming within, turning the planet into a kind of planetary generator. Not a dynamo powered by molten core convection, but by exotic chemistry under crushing gravity. This could explain the unpredictable magnetosphere. It could also explain why radio emissions recently detected from Neptune are not consistent with previously observed patterns. They're deeper, sharper, almost rhythmic. That's right. Neptune is transmitting. Not communication, but structured electromagnetic bursts, as if energy is being released through a valve. Researchers are now analyzing whether these emissions align with internal pressure cycles, perhaps the result of phase transitions between exotic states inside the planet. In other words, Neptune might be self-regulating. Or worse, unstable. Tyson's team also introduced a radical consideration: that Neptune's anomalous readings are not isolated. They might be resonating with other distant planetary bodies, particularly those in the Kuiper Belt. That would mean the eighth planet could be part of a larger gravitational system, one that extends into the uncharted outskirts of the solar system. One that pulses. One that influences. What if Neptune isn't a loner? What if it's a node, a gravitational anchor for a deeper system of mass we haven't yet seen? This could rewrite our models for how the solar system evolved. Because Neptune is not native to where it is now. According to migration theory, it formed closer to the Sun and was pushed outward by chaotic early dynamics. In doing so, it sculpted the outer edges of the solar system, bending the orbits of comets, dwarf planets, and possibly ejecting a fifth gas giant entirely. If Neptune's structure is fundamentally different, more chaotic, less dense, more active, then that history becomes something else. Not a migration, a reconfiguration. As the data continued to unfold, another mystery emerged, this one buried not in the planet's structure, but in its winds. For decades, Neptune has baffled atmospheric scientists with the fastest winds in the solar system. Over 1,300 miles per hour. Stronger than anything on Jupiter. More extreme than the Great Red Spot. Until now, the assumption was simple: solar energy and rotational speed drive jet streams. But Neptune receives only 0.1% of the sunlight Earth does. So, where is that energy coming from? The new data paints a chilling picture. The winds aren't being driven from above, they're being driven from below. Thermal plumes, shock pulse events, appear to be rising from deep within Neptune's interior, feeding angular momentum into the upper atmosphere. These aren't like Earth's convection cells. They behave more like internal detonations, silent, slow, and nearly invisible, but capable of shaping global storms. It's the first real evidence that Neptune's weather systems aren't just atmospheric, they're planetary-scale reactions. Reactions to what? We still don't know. And then there's the implication for exoplanets. Thousands of mini-Neptunes have been detected beyond our solar system. For years, we modeled them based on what we believed about our own. But if our Neptune, the prototype, is something else entirely, then every assumption about those distant worlds begins to collapse. It's possible we've misclassified entire categories of exoplanets. That means we may have overlooked environments that could harbor extreme chemistry, exotic physics, or even conditions suitable for life, though not life as we know it. Not warm, not Earth-like, but alive in the thermodynamic sense, cycling, evolving, reacting. In the depths of pressure, there may be order. And within that order, there may be intentionality. Neil deGrasse Tyson stopped short of making bold claims. But the data he presented pushed the edge of what we consider natural. And more than once during the stream, the words he used weren't scientific. They were philosophical. What we're looking at may not be a planet anymore, at least not in the traditional sense. It may be something in transition, something between states. Others have begun calling it a failed star. Not in the fusion sense. Neptune doesn't have the mass for hydrogen fusion, but in behavior, in structure, in internal feedback. Some theorists suggest Neptune may be the remnant of a sub-brown dwarf, an object that began forming like a star, but was cut off. What we see today, the icy blue sphere orbiting in the dark, could be the cooled, calcified core of something that almost was. If true, it wouldn't be alone. There may be hundreds, even thousands, of planetary mass objects that fall into this gray category. Too structured to be called random gas blobs. Too volatile to be traditional planets. Caught in the middle. chaotic equilibrium. But perhaps the most unsettling observation comes from what wasn't detected. A region near Neptune's south pole appears to emit no measurable background radiation. Not low radiation.
None.
An anomalous cold spot. A void within a planet that's already colder than liquid nitrogen. And it doesn't move with the atmosphere. It sits perfectly fixed, like a cap over something deeper. Simulations suggest this zone could be a pressure funnel, a vertical shaft where magnetic fields collapse inward, guiding charged particles to an unknown depth. It behaves almost like a conduit. But to what? That's the question Tyson left hanging in the air. And maybe he had no answer. Because maybe there isn't one yet. But the message was clear. Our understanding of Neptune is broken. And the tools we've used to define it, orbital mechanics, atmospheric chemistry, magnetic modeling, are no longer enough. It's not that Neptune is misbehaving. It's that it's revealing a deeper truth. Planets are not just spheres. They're systems. And sometimes, those systems evolve in directions we've never imagined. If Neptune is the key to reinterpreting the outer solar system, then we must begin again. From the migration of gas giants, to the ejection of planetary bodies in early solar chaos, to the unseen influence of objects beyond Pluto, it's all connected. And now, the planet we thought we knew, the quiet, stable ice giant, may be the most complex, most active, and least understood world we've ever observed. Some planets warm slowly, some collapse, some just drift, but Neptune pulses. If this has left you with questions or answers of your own, leave a comment below. What do you think is happening inside Neptune? Are we witnessing planetary evolution, or something entirely new? Subscribe if you want to be here the next time the darkness gives up one of its secrets. Like this video to share the mystery with those still looking up. This isn't the end of the Neptune story. It might be the beginning of another.